So in my last class, we have come up with, to understand what are the things that are needed to learn SQL DBA. Okay, yesterday's classmate, we discussed that part, right? And during the discussion, I clearly have said you that uh, yeah, let me just mention few introduction points. Few introduction points. Introduction to SQL Server. Yeah. SQL Server is a product of Microsoft. Introduced in the year 1989 as SQL Server 1.0. That is your version. SQL Server version it is 1.0. What we can do with SQL Server is this is the description you can say. Using SQL Server, one, we can create and manage databases. One, plus supports what it supports something called BI, business intelligence features. That is with SSIS, SSAS, integration services, reporting services, analysis services. Okay. Now, another interesting thing, connecting with SQL Server, what you study is, as I said in the top, that every, not only SQL Server, every RDBMS is a collection of two parts. Two parts. One is called non-procedural and second is procedural. Non-procedural is your SQL and procedural is your programming that you do with T-SQL. Yes. And what SQL Server supports? Obviously, both of them it will support because it is also an RDBMS. Both it will support. SQL Server supports what? SQL language. Who developed this SQL language? SQL is a language or product. SQL is a IBM product. So it means it is developed by IBM. I'm talking about language. SQL is whose product? IBM's product. What type of language? Non-procedural. Non-procedural language. And most important is SQL is common database language. Why it is called common database language? Since it can get understand by every RDBMS. And another interesting thing is SQL is case insensitive language. In any case you write, database understands it. Uppercase, lowercase, mixed case, any way you write, database understands that language. And how does it go? Yeah, this is the approach. This is the approach. User or your application. For two approaches you can call. Two approaches. Yes. To and fro, both. It will go to where? No? SQL Server. And from there, where does it go? Database. Yes. Database. Application. This is how the approach will be when you're working with what? Database. Yeah. And one more interesting thing here, what you learn is SQL Server provides two types of environments. Yes. Two types of environments. One is called stand-alone environment. And second is clustering environment. Yes, two types. Standalone and clustering. Yes. So let's be clear on actually how the process will go to understand the concept of stand-alone environment. Okay? So, all right, let's discuss small, important points I'll cover, and we'll try to understand the total standalone environment through architecture. Okay. So, what is standalone environment? You can say like this. Standalone environment. What do you call? It is helpful for small companies. Yes. Small companies. And it has only one production server. Yes. In standalone environment. Helpful for small companies. And it has how many production? Only one production server you have. And what happens in clustering then? In clustering, what happens? How the approach will be in clustering? Yeah. So you can say stand-alone environment is helpful for small companies, and it has only one production server. Acha, what happens in clustering then? Whereas clustering environment is helpful for large companies, and it has more than one production server. More than one production server. Yes. Standalone mein how many are there? Only one. In clustering, multiple are there. Okay. Second rule we study that in stand-alone server, all users are connected to a single server because you have only one production. Then what happens in clustering? Whereas in clustering environment, group of servers will be made available with a common name and common IP address. Yes, this is how standalone and clustering differs, right? Clustering has lengthy, a different level of architecture you would find. So let's be first clear on actually how a standalone environment is going to work with. We'll make one simple architecture to understand how standalone environment will be, because you have only one production server. Then slowly, as and when we progress, we'll definitely get back to you on how clustering environment will be. Okay, two things you focus. Chalo, let's first understand standalone. Yes. So this is the architecture of what standalone. And you be clear, please, be clear. What exactly I'm trying to come up is how standalone environment will be in real time. Because you're talking about small company, they don't need multiple production servers. One production server is enough for them to manage. So considering that, we are talking about the process. Okay, chalo, right. Assume now, here, let me just mention, I'm talking about standalone environment. Standalone environment. Okay. Now, in this standalone environment, something interesting for us is, yeah, here, considering this scenario, what? Assume this is one website. This is one website. Okay. What that website will do, I'll explain. Wait. What that website will do, we'll try to understand. Okay. So assume that this is your website. In this website, you have web pages. This is one web page. This is one web page. So you assume like this, no? This is like shopping portal. This is like shopping portal. Amazon.com, Flipkart.com. Yeah, you assume in that way, so that you can easily understand what I'm trying to come up with this picture. Okay. So this is your website. Okay. And this website is being handled by one team in the company. The team is application team. Yeah, there is one company, right? In that company, who is taking care of application team. They're taking care of that website. Where is that website running? Yeah, this website is running on one server called IIS server. Yes. IIS server. This website is running on IIS server. And who is accessing it? Assume you put yourself in the example. You are end user who is working on that shopping portal. You are the one who is working. You put yourself in the example. You are end user. You are the one who is working on this shopping portal. Yes, end user. So what end user is doing? End user is communicating with this website, and he is ordering some products. He's ordering some products. Yeah. And whatever the products he's purchasing from this shopping portal, that product's information should be recorded, no? think real time, you think real time. I open browser, right? And after opening the browser, I open Amazon.com, Amazon.in. This is my shopping portal. I opened. So I'm an end user now. I am an end user. And what I'm trying to do, I am trying to communicate with that website where I am going to purchase some products. Okay. Whatever the products I purchased, that product's information has to be recorded, no? Has to be stored, no? So that Amazon.com can see what are the products I have purchased. Those products they can deliver to me. So in order to store that information, assume this website is using SQL Server software. Yes. So that website in background, it is using what? What it is using? SQL Server software it is using. Okay. Chalo, right. Let me mention here. So this is SQL Server. Yes. What do you call SQL Server? Is your RDBMS? SQL Server. What do you still call this? RDBMS. Yes. RDBMS. And this SQL Server has one database which is connected to it. Okay. This is database. Yes. What it is? Database. Okay. Which is going to hold the information about the sales that are made on the website. Okay. Yes. This is the database. Yes. Database. Which database? Assume sales database. Whatever products you have ordered, all that information is recorded in this database. And name of the database is sales database. Which database? Sales database. And how it is transferring the data? Obviously, from SQL Server, the information is going to store in database. And even that information will be helpful in retrieving also. This is for storage and this is for retrieval. Storage process, retrieval process. And how would you do this? Using a language called SQL. So the only language that can talk to database, that can communicate with database is what? SQL. SQL language is used for communicating with what? Database. Okay. Now, indirectly, can you say like this? The website on which we are working, that website has a connection with this SQL Server software now. Yes, whatever the products you order here, that product's information will go and store in SQL Server. Yeah. So indirectly, can I describe like this? Yeah, there are two environments available. Two environments. This part is front end. Yes. Front end. This complete part is front end. And this part is SQL Server part, I'm saying. SQL Server part is backend. Yes. Two parts. Website on which you're working is front end. The website on which you're working is front end. And SQL server is what? Backend. Backend part. Two parts are working in your application. Okay. Now interesting thing. For example, assume that this website is connected to this server, And now imagine the situation that something happened on this server, some issue has been created on the server, and that server is not working. Which one is not working? This one, this SQL server is not working. Right? Already this end user has purchased two products. He ordered two products and both the products information is recorded in this sales database. Sales database. That products information is recorded. And after some time, still he's purchasing. This end user is still purchasing. But meanwhile, this SQL server got some problem. This SQL server has got some problem. Then database will not be working. Then that end user, whatever products he has ordered, the other products what he has ordered, that information will not be recorded. Then it will be a very big loss to the company. It will be a very big loss to the company. Very big loss to the company. So for that reason, what companies will do, always they make a backup. Yes. As it is, they make a backup. Backup. Yes. Backup you call, copy you call, you can say clone you call, clone, copy. Yes. And what is that they do? What they do? Okay, now two servers you have now. Two servers. See, servers are two, but only one will work at a time. I'm not saying like both of them are in action. No. So I mean, this is my primary, or you can call principal server. Yes. Primary or principal server. And this is supporting server. You can call this as secondary or standby server. Yes. Secondary or standby server. This is what? Principal server. Yes. And what is that you have? Obviously, same database. This is one more SQL server, two SQL servers now. One is primary server, one is secondary server. Standby, supporting server. Is this also connected? 100%. This website has also connection with this SQL server as well. Yes. How do you do this? How do you link this? How do you make connection with these two? Yes, first let me show you. This primary and this standby. Remember, they both are connected. They both are linked. Yes. They both are connected. They both are linked. How do you do this? How do you link them? Yes, to link them, we have got two most important concepts in SQL Server that we are going to study with the practicals in my coming classes. One is mirroring. That's called DB mirroring. And second is called log shipping. Two topics, database mirroring and log shipping. These are the two concepts by which you can make one server to become primary and one server to become standby. Yes. One server will become primary server and one server will become what? Standby server. How that primary and standby server are connected, that is what I was saying. Mirroring and log shipping. Those are the what do you call them? They are called high availability features. High availability features. Like not only two, we got around 4 to 5 features of that kind. Replication, mirroring, log shipping, always on, clustering. These all are categorized as what? As what? High availability features. Comfortable? Are you following me? What I'm trying to convey with this architecture, both of you, Puneet, Salini?
Yes.
Okay. Salini, what about you?
Yes. Yeah. Yes, I understand.
Okay. Now situation is, remember, this part I'm saying, this part. Let me just keep this part. Here, I'll take this in color and I'll say here. What backend process I'm talking about? Backend process. Okay. So from here till this point, from primary server to, you can say, standby server. This complete part is your backend. And now my concern is, for example, let me draw again. Yeah. Okay. Now I'll say, now listen. Now what I'm saying is, this primary server on which this application team, that application is connected, that this website was connected with primary server, and information, whatever this end user was ordering the products, everything was getting stored in database. Imagine a situation, something happened on this server got failed. If that database server is failed, the moment the database server is failed, remember, automatically, what will happen? Standby connects, standby links. Yes. Standby becomes primary. Yes. And you know one thing, whatever this website was taking orders from this customer, different products which he has purchased, all the information was stored in this sales database parallelly. With a support of this mirroring and log shipping, the same data was getting recorded in this database also, parallelly. When it was storing in primary, simultaneously that information was getting stored even in standby, even in secondary. You understand what is my point here? Whatever the products he has ordered, where it was actually getting stored in primary server. In which database? Sales database. And what happened? That same information was getting copied. The same information was getting copied even into what? Standby server. Why? Because if primary fails, standby will be ready. Standby will be ready. And he should not know, end user should not know that something happened at company server. No, that is not, we don't need to know him what is happening in the server. He should be, even if it is failed, automatic, it should switch over. It should switch over from where to where? From primary to standby. Automatic. When you see this practical, then you get more clarity that how this process is going on. Now one more point, please. Now listen carefully. One more additional we are talking about now. For example, say you put yourself in the example. You are a DBA now, right? Puneet is DBA, Salini is DBA, right? Now assume me also one DB. We all are at office. We are maintaining this server. We all three are maintaining the server. And that server was perfectly working when we all three were in the office. We all three. Puneet was also there at the server. Salini was also there at the server. Myself was also there at the server. Properly things were working. Properly things were maintaining. Every information was being managed perfectly. And at about 6 o'clock or 7 o'clock, slowly we started leaving office. Puneet left office at 6 o'clock. Salini left office at 5:30. I left my office at 6:30 or 7. Right? And after that, some other team, one more team who works at night shift, they were in the office now. They were at office. And we are all senior DBS. Now, point is, after leaving office, all of us, after leaving office, some problem has been occurred in primary server. Compulsory, Puneet should know that primary server got issue. Salini should also know that primary server got some issue. Even I should know some primary server has got some issue. Yes, for that reason, remember, we are going to make one tool available here. Yes. One tool we will make available. Yeah, you consider special tool you call, no problem. Special tool you have to install, you have to configure, you have to link with SQL server. What is the tool? TT. Yeah. This is one tool. Yes. Okay, let me expand and write. On the top, I'll write ticketing tool. Ticketing tool. Oh, we have many ticketing tools. Many. Some of them I'll just mention for your reference. Just for your reference. Some of the tools. Let me write here. Some tools. Name of one tool is HPSD. This is one tool. Okay. There is one more tool by a name called Kayako. This is one more tool. There is one more tool by a name called BMC Remedy. Yes. Right? Let me show you. BMC Remedy. Can you see that? Ticketing tool. BMC Remedy ticketing tool. Yes. Right? You have to download. Okay. And one more tool I said, no? HPSD ticketing tool. HPSD. Right. Is a ticketing tool. HPSM, HP Service Manager. And HPSD is also there. Yes. That is also one tick, one. This one. The other one I said what? Kayako. Kayako. Can you see? Ticketing tool. This is also ticketing software, Kayako. Here, can you see here? Optimizes customer service by enabling teams respond faster and more accurately. These are some of the examples I gave. We have latest ticketing tools even more stronger, included with some powerful AI features in it. Now what will happen, what will happen, what we do, we know that is server, na? You cannot guarantee, right? What you cannot guarantee, that every time server will be working accurately, perfectly, and 24/7 that server will never get problem. No, you cannot guarantee. This may happen that till you were at office it was working. After you leaving the office, some issues have come. Immediate. What should happen? Yes, this server will send something called, you understand this term, right? Email. But in database terminology, it is called DB mail, database mail. For database, DB mail. For commercial purpose, for other information, electronic mail, email. Now I'm talking about DB mail. Yes. This DB mail, we only will configure. We are only going to write that process. You understand? In that process, we will say, what we will say? That the moment primary server is failed, immediate, you will be getting a DB mail. You will be getting a mail. Who will send that mail? Ticketing tool will send. To whom it will send? Yeah, obviously, it will send that information to 3 people, the main pillars of this total process. Client. Where are you in the picture? Yes, you are here now as a DBA. Yes, you are here. Yes, we are here. You assume this is DBA. Yes, here I am. DBA. And we are not at office. Don't forget that. We are not at office. We are at home now. We are not at office. We are at home. And server got some issue. Immediate database mail via ticketing tool that will send DB mail to DBA. It will send DB mail to DBA. It will send DB mail to the client who is the owner of that website, and it will send the mail even to application team. Yes. To all of them, so that they all can become active. They can immediately react. That is the reason why we call, you remember that? This is what you call database administrator. Database administrator. Listen carefully, please. 2 terms I'm using, 2 terms. DBA should be either proactive or DBA should be reactive. Database administrator should be proactive, or database administrator should be what? Reactive. Proactive in the sense, maintaining things properly. Day to day, you maintain things. Day to day, you go through the things. Day to day, you look into that, small issues. Never you come across with big problem in your server. Like example you take. As for a human being, health, how much important? Health issue, right? You go with proper diet, you go with proper exercise, you go with, proper health, with respect to maintenance. Never you fell sick. Never you get any health issue because you are maintaining everything properly. You're maintaining your health in a systematic way. Never you face problems. Proactive. In time sleep, in time your breakfast, in time lunch, in time dinner, in time proper sleep, in time exercise. You understand? Healthy food, healthy food, right? Why? Because it is my health. I need to take care of my body. Proactive. But despite even taking, sometimes, you may fell sick. Yes. Though you were maintaining everything properly, but due to some, disease that got spread, we are affected of it. Some problem. And it is small health issue, small health issue. What is your job now? When you're affected with some problem, instead you react, visit to doctor, whatever is asking, immediately you try to do all the things in a proper way. You understand? See that small problem should be removed in small time. Don't drag it. Don't delay it. Don't delay it. Because of one delay, that may cause another problem for us. Don't delay. Instant react, instant try to rectify the problem so that you may not put into trouble with some other issue in it. That is called what? Reactive. Now see the problem. You are not at office, right? But you got a mail. Become active. Immediately contact the people who are there in the night shift. Call them, inform them, get to know what the problem is. Try to identify what the issue is. Because we have only one standby server. If that is also felt, then then there will be a big problem in the company. Then you approach, you talk to the guys, you communicate with them, you explain, you try to know what exactly the problem is, the issue is. You understand? And if you find, oh, this is a small problem, obviously once you are experienced, once you are habituated, once you are, you're habituated of knowing, all the issues thoroughly, in experience, we come across with a lot of issues to resolve day-to-day activities. Then definitely once you are experienced, whatever the issue that has come because of primary server got failed, you may find that it will be a small issue. Then you communicate with the guys who are in the night shift, then inform them this is what you do, so that that server can become active again. Yes, you guide them, you inform them. And when you inform, when those people are doing, say for example, the problem has been solved. The moment the problem has been solved, remember, you are now working with this standby, which is currently for you is primary. And that primary, which was earlier, now automatically that becomes standby. Automatically, that will become what? Standby. And in this total architecture, in this total architecture, whose percentage of working is more, front-end people. Front-end people efforts are 70% and back-end people efforts are just 30%. See the comparison, please. How much is your job profile task and how much is front-end developers profile job? They are the one who are going to have 70% of their efforts. And we are just 30%. Why 30%? Because every day you don't do primary server. Every day you don't do secondary server. Every day if you don't create database. One time you do, one time. Every day you don't configure mirroring. Every day you don't configure. One time you do. On that day, little efforts will be there from your end. After that, It's only a job of maintenance. Properly you maintain. Bus over. Never you get a problem in it. Yes, this is what the standalone environment that could be managed in real time. Yes. So from my end, I'm done. You have any question that you would like to ask me on this? Go ahead, please. Any question, any question.
Sir, if secondary server is also failed, then what happens?
That is what, na? Small companies, suitable for small companies. That is what I was saying. Suitable for small companies. Obviously, if this also, immediately, if that is also felt, then everyone becomes helpless in that case. Everyone becomes helpless. That is the reason I said reactive. Once you find a problem, try to rectify that problem immediately. Because even in problems, we got categories. Even in problems, when DB mail comes, you are going to configure that problems also with categories. Something like, critical. Critical is immediate. You have to instant react. And sometimes, little mid-level problems, low-level problems. So based on those, you should react. Based on those problems, what are highlighted in the ticket, what are highlighted in the database mail, based on that, you react. Do you understood, Puneet, what exactly I said now?
Yes, sir.
Okay. Yeah, Salini, you have any questions to ask me on this?
No, sir.
Comfortable? You understood what I tried to convey with this architecture?
Yes.
Huh?
Yeah, I understand. I understand very well.
Right.
Sir, here mirroring and log shipping, there you said always on, right?
These
అంటే
all
అక్కడ
comes under high availability features.
Okay.
High availability in the sense, data is always available for end user.
Okay. In high availability, it will come mirroring, log shipping, and always
shipping, replication, always on, clustering.
Cluster. Okay.
5 powerful.
Okay. Another 3 also we have. Okay.
Yes. Clustering is a network environment only. Here I said only one production. No? Here. In standalone environment, I said only one production. No? And the other one was standby, right?
It
have
means
how many production servers? Only one production server.
Only one production server.
Only one production.
If
Yes.
How many subsidiaries servers we can create, sir, in each primary server? Only one or number of
only
we can
one.
create?
No. Only one. In standalone environment, you'll have one primary server, one standby server. That's it.
Okay.
In clustering,
Okay.
till SQL Server 2008, we used to have 16 servers.
Okay.
16. And we call them actually 16 nodes. NODES, 16 nodes. Till SQL Server 2008.
16.
After the SQL Server 2008, from SQL Server 2012, Microsoft has made more flexible. Now Microsoft says that in clustering environment, if you are working with SQL Server 2012 and higher version, there is no limit at all. Now you can have unlimited nodes.
Before 16, now unlimited nodes we are using.
Nodes. No limit for the nodes. That was there 16 nodes till 2008 only.
Okay.
And from 2012, no limit at all. Now it depends like how much your company can invest, how much your company can make investment on to create a setup for your multiple.
Depend upon the business. Okay.
Yes, Salini, ask.
Depend upon the business, sir, we will create the servers.
Exactly. That's what I said. Na? For small organizations which cannot afford big, they have limited users working. They have less number of, transactions going on the database. Then for them, this is suitable. This is enough for them. A big organization where they have thousands of users working on the database, and they got many databases created in that, and one database size is in terms of terabytes, then this standalone will not be suitable for them. They have to switch over to clustering. Clustering setup, I'll explain. Such type of architecture, I'll explain. Coming classes, I'll explain. So that you can
Okay, sir.
understand how, and one more point, clustering environment will be managed by, not alone DBA. DBA alone cannot manage clustering setup. You should have at least 5 categories of administrators. Five categories of administrators. They can maintain clustering complete setup. 5 types of administrators, including DBA in that. DBA is one kind of administrator. Network administrator, Windows Server administrator. Types of administrators I'm saying, who are involved in maintenance of clustering setup.
Okay.
Comfortable? Did you get this? Did you get this point?
Yes, sir.
Okay.
Yes, sir. Understand.
Yes. Considering or keeping these things in view, tomorrow's class, I'll continue and explain you the next part of this topic. Acha, let me mention that point also. The one which I said you just now about the 2, what do you call, environments, no? Where I should write? Somewhere here I'll insert here that point here. For clustering environment in SQL Server 2008, 16 nodes can be created. And from SQL Server 2012 and later releases, there is no limit. Yes, you can have any number of servers. Okay. Now, after this, I'm going to talk on roles of DBA. Roles of database administrator. All the roles I'll describe, all the roles. Then we'll discuss one by one where we are involved, what are the activities, how we are going to work, everything we'll discuss that. Okay, Puneet, was it clear? Did you understand all the points what I tried to convey with this architecture?